All right,
Oh,
friends.
no.
Try youtube.com/webcam, which isn't going to work for us, I don't think. Well, we may be making the transition away from YouTube. Who knows? We shall see. I'm just seeing the note here. I'll give the webcam thing a try. But as far as I know, it doesn't let the hangouty things happen unless they have changed it. So, well, yep, gonna have to change things around. But we're here. No Justin tonight. No Justin tonight. I hope everyone is ready for a show. We have science. Blair and I gonna talk about science with you. It's gonna be a night of science goodness. There we go. I'm gonna retweet Blair's tweet because that's what we do. Blair, are you almost ready to do a show?
I'm so close. Give me 1 second.
So we are missing Justin kind of last minute, and as a result, we've had to scramble a little bit more than we were expecting to tonight. So there are a few little things. Oh, like I forgot to put some things in there. Maybe. I can write things down. What do we have in the show tonight? I can figure that out.
Okay. Okay. Great. Okay. Je suis prête.
Oui, je suis prête aussi. J'ai écrit sur le table. Sur le spreadsheet. Oui. All right, are we ready to go? We're ready to go. We're going to do a show now. Starting. I love seeing all of you in the chat room. Who's over there on YouTube? Oh, we got people on YouTube. Hey, Del Marais. Hey, Paul Disney. Welcome, 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 everyone who's here. We are beginning in 3, 2. This is TWIS. This Week in Science, episode number 726, recorded on Wednesday, June 19th, 2019. Missing Persons. I'm Dr. Kiki, and tonight on the show, we will fill your head with zebra stripes, earth twins, and sneezing plants. Achoo! But first,
Disclaimer, disclaimer, disclaimer. The tides go in and the tides go out. The world goes round and round, and we try to predict what will happen each new day. But sometimes there are unexpected events that take us by surprise. What we do with those surprises defines who we are and what we will be tomorrow. Tonight's surprise is that Justin is somewhere in America where there is still no Wi-Fi. So with that surprise, we will bring what science we can and what spirited discussion we may. Pull up a chair, relax, and listen to this very special episode of This Week in Science, coming up next.
I've got the kind of mind that can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki.
Good science to you too, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back again. It feels like I was just doing a show this weekend.
I know, I just saw you.
I
Like
just
day
saw you.
before yesterday.
Yeah, that was pretty
great.
fun.
Oh my
That
God, that's so
episode, that podcast episode from the Interplanetary Festival will be coming out very soon. So stay tuned for that in your RSS feeds if you catch this as a podcast, if you're subscribed to the show. On tonight's show, we have some wonderful science ahead. I have news about hidden DNA revealing dark corners of our chromosomes. Dun, dun, dun. Also, some new Earth twins, little Earth twins, and the aforementioned sneezing plants. Yeah, bet you didn't know plants could sneeze. We'll find
No.
out more about that in a
I
bit.
did not.
Yeah. Blair, tell me what is in the animal corner.
Oh my goodness, I have zebra stripes, I have codependent fish, and I have smelly dinosaurs.
Smelly dinosaurs. How
Yeah.
would we know if how smelly they were?
You'll find out.
We'll find out. We will indeed. On the show that is coming right up, as we jump into it, I would like to remind you all that you can subscribe to TWIS if you are not yet subscribed on iTunes, YouTube, or on the Google Podcast portal. We're also on Facebook. You can find links to these things at twis.org, as well as a link to our Patreon account. If you're interested in supporting what we do, consider checking that out. Now, into the stories of the day. So let's talk for a minute about chromosomes. Blair, what do you know about the centromeres?
They're the little
chromosomes.
buttons on the chromosomes, they're little dots. That's pretty much all I remember from high school biology. They're little circles.
They're little circles. Well, that's not exactly true, but they are sections of DNA that are very important for lining up the segments of our chromosomes during cell division.
Yes, that's the buttons. That's what I
They're
meant.
the
It's
little-
where they connect.
Sure.
It's coming back. It's coming back.
It's where they connect. But they, aside from just where they connect, it's also a place where crossover events do not occur. And so during cell division, our chromosomes line up. The centromeres kind of have these filaments that bring everything together. Its filaments pull everything in, and the chromosomes line up. And then there are crossovers at various points across the chromosomes that result in increased diversity because you're taking the chromosome, say, from one parent or another parent and changing information from swapping information from one to the other. And so during this process, the centromeres kind of hold everything together while everything else is swapping around, doing their crossovers. But to this date, because of the way the centromere is structured, it's been very hard for researchers to accurately sequence the information within that area of the genome. And so researchers kind of consider it this heart of darkness. So, according to a UC Davis evolution and ecology professor, Charles Langley, he says, it's the heart of darkness in the genome. We warn students not to go there. So he's a senior author on this paper that was published in an upcoming issue of the journal eLife, along with Sasha Langley, Garen Carprin at the Lawrence Berkeley Laboratory, and Karen Miga at UC Santa Cruz. Together, these researchers determined that there could be groups of genes that get inherited together that stretch over and across the centromere. And now these groups of genes that get inherited together are known as haplotypes. And so if any of you have done, say, 23andMe, the genetic analysis of your single nucleotide polymorphisms will give you a particular haplotype that is used to help identify how long your lineage has been evolving and when you potentially first appeared on the scene, when your ancestors first appeared on the scene. It can take you back that far. Because the centromere doesn't have that crossover stuff that happens during cell division, they then hypothesized that they could look if they could look in the centromere a little bit more accurately, then maybe the genetic information in there is very well preserved because it hasn't been shuffled like everything else. So these haplotypes that kind of, if there's a haplotype that stretches across the centromere, then that haplotype will have segments of itself that don't change for a very long period of time. And so they looked for single nucleotide polymorphisms, these little single letter base pair changes in the DNA that would allow them to get this measurement of what was going on within the centromere and these haplotypes. So, number one, they did identify what they call senhaps or centromeric haplotypes in Drosophila fruit flies. And so that insinuated to them that, hey, this is a thing. We've got this DNA that doesn't change and we can log it across the centromere. Now we tried it in fruit flies. We can see that we can do this. Now let's look at it in people. So they went to human DNA, they went to the 1000 Genomes Project, which is a public catalog of variation in DNA, and they looked at haplotypes that they found going across the centromere in every single human chromosome. Some of these sequences are old. They go back hundreds of thousands of years. Not tens of thousands, hundreds of thousands to 1,000,000 years. So these sequences of DNA have been preserved. They're like DNA fossils within our own genomes. In chromosome X, so the sex chromosome for females, they found these senhaps that went back 500,000 years, 500,000 years. And they were able to identify this diversity among African genomes that identify with the recent spread of people out of Africa, out of the African continent. And they went back far enough, they found that one of the oldest senhaps was not carried by those African dispersers.
What?
Yeah, so one of the oldest haplotypes wasn't from there. On chromosome 11, they found haplotypes of Neanderthal DNA.
Okay.
They diverged between 700,000 to 1,000,000 years ago. And this is just about when Neanderthals and humans went their separate ways. Neanderthals speciated and went off on their own.
Before they came back together later.
Before they came back together again. Exactly. Yeah. And then chromosome 12 contains an older, more than 1,000,000 years old archaic haplotype that has yet to be identified as to who it comes from.
So, is it possible that at least the first one you were saying is from the Neanderthals? Is it possible that we got that one from an interbreeding effect later on? Or is the idea that they're pretty sure that this has been conserved since before Neanderthals broke off from modern humans?
For those particular senhaps on that chromosome, they think that they've been conserved going back at least that far. That there have not been many swaps, that there haven't been that shuffling of DNA that would occur there. And so these
Right.
are very well conserved areas of the genome. And because they're haplotypes, so it's DNA that spreads it's not just in the centromere, but all around it. So in areas that maybe would undergo shuffling, but because they're a haplotype, this is a bunch of DNA that all goes together. It all moves together. They are complete genes, and there are genes in there that aren't in the centromere itself, but maybe around it. There are genes there that influence our behavior. And so this further suggests that there is ancient DNA from Neanderthals and archaic ancestors that is still potentially influencing how we respond to things
Wow.
today. One of the things that they bring up is that the Neanderthal DNA on chromosome 11 could be influencing our odor receptors, and could these that Neanderthals, their how they responded, the genes they had, could be the genes that allow us to respond to smell today. And so, which is interesting because it really goes to, I mean, we talk about it all the time, this, this idea that there are so many things in us that are not modern, that they are carryovers from a long time ago and maybe are not adapted to modern society. And so are there aspects of the odorant genes from Neanderthals that are they influencing how we respond to stuff in a positive or a negative way? We don't know. But because those genes are there, that this variation is impacting us in some way.
Wow. Uh,
Yeah.
I mean, I guess it kind of makes sense in the whole idea of, I mean, in biology, in evolution, the saying, if it ain't broke, don't fix it, is kind of true, right? Like, unless something better comes along that is selected for, then things are conserved. So there's enough DNA in our body, in our system, that there has to be huge segments that for millions of years, like, wasn't broken, didn't come up with a better one,
Not broken.
doesn't
Yeah.
need to be changed. So it makes sense, but it's still cool to know that there's stuff in my DNA that's been there for a million years.
Yeah, for a million years. And another interesting thought that comes from this is because these are just groups of genes that tend to move together, get shuffled together, because they're around the centromere just by chance, probably, they're not being shuffled,
Mhm.
and they are standing up to, the test of time in terms of genetic diversification. And
And
it's
that's also a reminder of why.
based on their location, right?
Yeah, and
Yeah.
that's why negative
Mm,
elements in our DNA continue to persist. If they're linked to something that is still positive, that or neutral, then that negative thing that is linked to another thing could continue to go on. These sections of DNA are complex, and they could be coding for many different things.
yep.
Yeah, that's so, because if the better version of something that would cure a disease also is linked to something that is completely um, a reason for termination of
Mhm.
growth,
Right, yeah.
then oops, that better version of that one gene is connected to another gene that made the whole thing infertile. So
Mhm.
oopsie.
It doesn't match up, yeah.
Yeah. Yeah.
Yeah, those are gonna be very interesting considerations moving forward with medicine and genetic medicine, for
Mhm.
sure.
Yeah,
Yeah.
absolutely.
Well, moving on from inside us, let's go to outer space. My next story is a discovery. I love discoveries. And this one again, a discovery in the dark, not far from us, only 12.5 light years.
Oh, just a hop, skip, and a jump.
So close around a star, a red dwarf star, very dim. It's an M class, not very dim, very hard to find. We didn't really find it until 2003. This star is called Teegarden star.
Oh.
And I really the name, I'm sure it's somebody's name, but it's a very poetic name. Teegarden. Teegarden star. I hope that there are sonnets written about this discovery and this star. Looking at the star with a new device from the Calar Alto Observatory in Spain called Carmenes, which stands for Calar Alto High Resolution Search for M Dwarfs with Exo-Earths with Near Infrared and Optical Echelle Spectrographs.
Yep.
Or as Phil Plait over on the Sci-Fi Wire on his blog says, it means an extremely sensitive detector mounted on a telescope at the Calar Alto Observatory in Spain that looks for alien worlds like Earth orbiting very cool red dwarfs.
Yeah.
Like Teegarden star.
What's
And
that acronym? I wasn't tracking it.
yeah, we need a new acronym for the more accurate
Yeah.
for the lay description. This star was discovered 2003. They aimed the Carmenes observatory, this telescope, this detector on the telescope at the star, and they started looking for a wobble in the star. These planets, we talk about exoplanets that are and around this star, they discovered 2 exoplanets. That's the discovery. In finding these exoplanets, they do not transit the star. Usually, when we talk about exoplanets, we talk about the detectors finding a dimming of light because something is passed in between the star and us. Usually a planet, and we're able to determine size, so mass, maybe chemical composition because of the light spectra that we observe, and so all these things we're able to determine because of the dimming of the light and the change in the light spectra. Now, with these, they didn't transit. And instead, because of their mass, they actually have a gravitational pull on the star itself. And now, in all solar systems, the objects that orbit this central star, we think of the central star as being this stuck in space object, and then everything orbiting around it. In reality, that star is also has a little orbit. It's rotating on an axis, and it also is orbiting, just a small orbit, and that orbit is very often determined by the movement of the massive objects around it. And it's a wobble. It's a little bit of a off-center movement when we look at the light from the star.
Is this
Now,
a commonly known thing?
To astrophysicists,
I
they look
wow.
for it's called the center of gravity. And
Yeah.
yeah.
It makes perfect sense, but I had no idea. That's fascinating.
Yeah. It is fascinating. So it's not that star in the middle, it's not just static in space. It is influenced and it's moving in space just like it's a big old wobbly system.
Hmm.
And so Carmenes was able to look at this wobble, and what Phil Plait calls it is reflex velocity, this tugging, this wobble, the reflex velocity. And this creates a Doppler shift in the light spectra that we see. So if it's wobbling away from us, it's going to, was it blue shift? And then if it comes toward us, it's going to red shift, or the other way around. Probably
I
getting
think
it
it's the other
backwards.
way.
It's the other way around. Yes. Moving away, red shift, moving toward us, blue shift. But there's a change in that spectra, and it can be seen when when the device doing the looking is fine-tuned enough. And that's exactly what the Carmenes detector did. It looked at this star. It was able to find this wobble, and it appeared that the wobble could be described by 2 planets, not just one. They have called the inner planet Teegarden B. It has an orbit that lasts about 5 days, and it is only 3.8 million kilometers from the star. Mercury, the closest, according to Phil Plait, is 60 million kilometers from our sun. So it gives you an idea of how close this first planet is to Teegarden. The second planet, Teegarden C, has a much longer orbit of 11 and a half days. So this one is only at a distance of 6.6 million kilometers. And both of these planets are just about, based on this reflex velocity and what they were able to see in the Doppler shift of the light of the star, just about the size of Earth. Maybe slightly bigger, but pretty much Earth-sized. And because this M-class star, this red dwarf, is dim, it is incredibly dim. It puts out just a fraction of the light that our sun does. 0.089 times the sun's mass. It is only 1/10 the diameter of the sun, and it shines 7/10,000ths of the sun's luminosity. So 0.00073 times the sun's luminosity. So it's super dim. There's just no energy coming out of it. It's really cool. It's half the temperature of our sun. The temperature of our sun is about 5,500 degrees. It's about half that. And this whole system can be as small as it sounds with these planets so close to the star, and they are still in the habitable zone.
Wow. That's where I thought you were
12.5.
going. That's
Yep.
funny.
12.5 light years away. A little tiny solar system. There may be other planets, but we haven't noticed them yet, with two that are very close. And this ties in with a lot of evidence that seems to be accumulating lately that these red dwarfs are very common in the universe. And rocky planets seem to make up their inner planets. So it's very possible that these little Earth-sized planets in the habitable zone of Teegarden are rocky. And if they are, they also may have water. But we don't know that. So these are the extrapolation of what they're made of and what's on them, their composition. That is just complete, it's questioning. It's an idea, but we do not know at this point. We just know that they're there. And something could be on them.
So our sun is a yellow dwarf. Is that right?
Yes.
I think. Okay.
Yeah.
So it could be that we're the weirdos. That there's all these red dwarfs where there's sun up and the sun is like enormous. It's the whole skyline because it's so close. And the year is super short and all this good stuff. And there's life there. And then there's life at all these other exoplanets on red dwarfs. And then we're the weirdos with our long year and our tiny sun from far away. And it would be interesting if that was the norm and we were the unusual ones with life at a yellow dwarf.
Yeah, so our sun is a G-type main sequence star.
Okay.
That's what it is. That is what technically it is known as. But yeah, when we talk about the evolution of a solar system, that dim red dwarf might have been much brighter at one point. Those planets could have been further away at some point, and things could have migrated in. Or, they could be like Mercury, and maybe this is, I don't know the age of this system, but this red dwarf star could also be it could have been brighter at one point, and maybe whatever habitability they had was all burned off because they are so close. So we don't know at what stage in its evolution the solar system, that solar system is at this point.
Interesting.
Yeah, so there are many, many questions as to the dynamics of solar systems when we find them, and if we do, could there be life, or was there before possibly, or will there be at some point in the future?
Yeah.
Yeah,
We'll have to go there and find out
we do. We
and
gotta
not
figure it out.
accidentally bring our own bacteria.
That's gonna be a problem because
Yeah.
there are things that are on this planet that don't mind the harsh realities of
Yeah.
space.
Yeah.
You're like, "Yeah, we'll just live
Oopsie.
on the outside of your spacecraft. That sounds
Yeah.
great.
Bunch of
Sure."
bacteria and tardigrades for you.
Exactly. Hey everyone, if you just tuned in, this is This Week in Science with myself, Dr. Kiki, and Blair Bazdarich. And if you want to support what we do, you can click the Patreon link on twist.org. Blair, I do believe it is time for a part of the show that we do love
What's
to
it called?
call
What's it called?
Blair's Animal Corner.
Yes.
Loves are creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels. Animal Corner.
Hey Blair, what you got?
Oh my goodness. I'm so glad you said it. I don't know if I could speak without it. I'm listening for the what you got, Blair. There it is. Okay.
What you got?
Great. So I have a story about zebra stripes, which first let me just give you a quick that whoever may be listening or watching a quick kind of recap in what we've talked about on this show. Over the past 7 years that I've done this show, we have talked about a bunch of different theories about why zebras might have stripes. The prevailing theory to this day is that it actually has to do with repelling biting flies. And this was first done in, I think, when I was still an intern. There was a study where they painted paint trays with stripes, and less flies landed on that one than the paint pans that were painted with just black or just white. And then more recently, I think just a few weeks ago, there was a study where they actually used live animals. They had zebras, they had horses, and then they had horses wearing zebra coats. And they were landed on less and bitten less when they had the zebra stripes. So they think that there's something visually going on there that repels the flies. But this study is a new one in being thrown into kind of the ring of why zebras may have stripes. This is something published in the Journal of Natural History this week, and it indicates that zebra stripes may have something to do with controlling body temperature, which was the initial hypothesis before the biting fly hypothesis surfaced. The authors of this study argue that there is a special way zebras sweat to cool down, and that the black and white stripes create small scale convection currents, which aid in evaporation, and this also might in turn repel biting insects. But most likely that this is a convection result from the black and white stripes.
Convection.
Yes. So this is through the British Natural History Museum. This is from amateur naturalist and former biology technician Alison Cobb and her zoologist husband, Dr. Stephen Cobb. They spent years in sub-Saharan Africa, where they've done many different research and environmental and development-based projects. But this is a new study where they looked at real zebras in the wild to look at the role of stripes in temperature control specifically. They collected data from live zebras. Do you want to guess how many, Kiki?
What was the sample size, Blair?
2.
Whoa.
A stallion
But with many
and a
stripes.
mare. There were many stripes. Then, and I mean, it was, I guess technically it was a sample size of 3 because they also put a zebra hide draped over a drying rack, like what they call a clothes horse. And that was their control so that they could see what just the skin and hair would do.
They should have
So
taken a horse out to where the zebras were and put a zebra skin on the horse out there.
yeah, that would have been good.
I mean, because then you've got, like, the temperature of the animal and all that, but anyway,
Yeah.
continue.
So, the middle 7 hours of the day are the hottest there, and the black stripes were 12 to 15 degrees Celsius hotter than the white stripes during that time. The stripes on a lifeless zebra hide on the clothes dryer continued to heat by another 16 degrees Celsius. So you have your white stripes and your black stripes on the living zebra. The black stripes are hotter by up to 15 degrees Celsius. But on the just zebra hide on the clothes rack, 16 degrees Celsius hotter across the board. So there is something happening. There's some mechanism suppressing heat in living zebras, which I would argue is sweat, because that's what mammals do.
Sweat, but also circulation.
Yeah.
Yeah.
So they are saying that there's some way, because there's a difference in temperature between the black and the white stripes, that the stripes are providing a cooling system. I would also argue that might just have something to do with wavelengths of light and how when you wear a white t-shirt, you're cooler than when you wear a black t-shirt. So moving on.
Yep.
Recent research had revealed, a separate study had revealed, that sweat in horses from the skin to the tips of their hairs is facilitated by a protein in the sweat called latherin, which also is present in zebras, which makes sweat frothy, which increases the surface area and lowers surface tension, so it evaporates easier. So the researchers propose that the differential temperatures and air activity on the zebras, on the two different stripe types, create a convective air movement within and just above the stripes, which destabilize the air and water vapor at the tips of the hairs. And this is what cools them so effectively.
Okay, so you've got the sweat being produced all over the zebra, but
Mhm.
because some areas of the zebra are black, they heat more, and so
Mhm.
you have increased convective cooling. Is this the
Mhm.
idea?
Exactly.
And because there's the stripes, then you have a
Mhm.
circulation because you probably end
Right.
up getting these convective currents that probably cycle. So zebras have their own wind. No.
Right. So here's the other kind of issue with that. This same duo attempted 40 years ago to test this hypothesis by looking at water in oil drums with differently colored felt coats. But it was not enough. It didn't really prove that there was a difference. So there's something going on specifically with what is happening inside and outside of the zebra, more than just the stripes. Something is happening differently with the way the stripes behave. So the other element of this that they are proposing is that zebras have apparently an unexpected ability to raise the hair on the black stripes like velvet while keeping the white hair flat.
That's fascinating.
Yes. So their
That's
proposal
huh.
is that by raising the black hairs during the heat of the day, when the stripes are at different temperatures, that assists with transfer of heat from skin to hair surface. And when it's in the early morning and there is no air movement, they can actually have their hairs flat, which helps trap heat
Mhm.
to keep them warm when it's still cold out on the savannah. So they think it's this
Hmm.
three elements together: the convective air movement from the two different colors, the latherin aided sweating, the frothy sweating, and the hair raising work together to allow the zebras to wick sweat away from their skin and create these convection currents to evaporate more effectively and rapidly and help them cool down. They also say, yes, it is likely that the stripes may also play a secondary role in deterring biting flies from landing on them because of the convection currents, that's what's wigging them out. It's possible. So this is the proposal put forward in this study. And I will say that the main researcher, Mrs. Cobb, she said, quote, "My early attempts 40 years ago at testing this hypothesis, with the oil drums, I lost my spot, was not a good enough experiment, and I wanted to see how the stripes behaved on live zebras." She continued to say, "The solution to the zebra's heat balance challenge is clever, more complex, and beautiful than we'd imagined. Of course, there is much more work to be done to gather evidence and fully understand how the stripes help zebras control temperature, but I am 85 now, so that's for others to do."
Oh, I'm getting old. I can't.
No more running around looking at zebras in Africa, I guess. But
So,
yeah.
looking at the paper itself, they're talking about all this convective air movement, but they
Mhm.
never measured that.
Mm-mm.
They have no measurements of these
Nope.
things, even
They only
though
have the
scientists
measure the temperature differences.
they have and yes, so they took the temperatures, they say, with a handheld digital infrared thermometer with a
Mhm.
laser guide. So,
Mhm.
they're pointing anyone who
Mhm.
has a kitchen infrared thermometer,
Mhm.
it's basically one of those to go boop, boop, and the laser points at exactly where you want it to measure, get a black
Yeah.
stripe, get the temperature, get a white stripe, get that temperature. And then additionally, they looked at the coat quality. So um, the black and white stripe temperatures of the zebra hide exactly the same way. Qualitative observations of zebra coats throughout the day and of
Mhm.
zebra behavior and physical responses. So it's the qualitative observations of the zebra coats that I am concerned about, and how they can accurately say that there is this change in the black versus the white stripes with
Right.
the piloerection of the
Yeah.
hair.
Which my question there is, if the white stripes are always cooler, why wouldn't the whole thing be white?
Well, being white is really terrible for being a prey species. We know that
Right.
albino animals are killed.
Right. But so that's kind of my point, is the stripes can't just be for temperature control.
Yeah, I mean, could they be for more?
Yeah, that's kind of what I'm saying, is that this study and the previous ones we've done they've downplayed this whole camouflage side of things. They're like, "Oh, it's for temperature control. Oh, it's for biting flies." It just like with a lot of things we talk about on the show, it's usually multiple things. So,
Yeah.
the idea that this is why they're it's no, they have white on them because it's cooler to be like it's less hot. But ultimately, if that's the reason that they're striped, there's no reason that they shouldn't be splotchy or have thicker stripes or thinner stripes. There's something there. They have to connect the dots between, okay, this is a disruptive camouflage formation. Why this one?
Right.
And I think
Right.
that's the part that is a disconnect for me, because I understand, okay, the black hair, they can raise up the hair. It's good to have heat and cool near each other and all this good stuff. But there's all sorts of different patterns that can achieve those things.
Mhm. Yeah, it's still a mystery because there still
Yeah.
is the biting fly aspect, which
Mhm.
has data behind it and
Mhm.
more data than the, 3 individuals
Yes,
that were
including the clothes
exposed.
hanger. Yeah.
Yeah.
Yeah. Yeah, so Kevin Unique in the chat room says giraffes have spots. Absolutely. So if
There are horses that have spots, that have
Mhm.
dark spots and are
Yeah.
lighter colored.
Yeah, and I
Uh,
think, yeah, something really missing from this study is looking at a splotchy horse. Look it up. It's is it palominos? Which are the painted ones? I don't remember. But the ones that have the splotches on them that are dark brown and white. That would be a perfect animal to test this on. Are you raising the hairs in the dark spots and not the light spots? Is there a temperature difference between the dark spots and the light spots? And in all cases, can we measure a convection current, please? That's what I want. Anyway, just thought I'd throw it out there because it existed in the science news for this week saying, we solved it.
But it's still not solved. But
No.
it's a nice addition to all of
interesting
the
information.
and it's an
It
interesting.
could be all of them.
Yes. Yeah.
Absolutely. It could be all of them. The real question is, was it a random mutation? Did they get black and white first and then they became stripes later? Were they stripes first and then black and white later? That's really the stuff that I think would help you identify what's going on, why a zebra has stripes. But
Yeah. What was the study? If you shaved a zebra, is their skin
oh yeah.
striped? There was. Do you remember?
I don't recall. So apparently their zebra stripes are hair, not on their skin.
Not on their skin. And they have dark skin underneath. So I think they're dark skinned and they have the dark hair and then white stripes with the white stripes. Yeah. I think that's what I remember from the striping and the skin. And you can't take the skin out of it. I mean, the hair is a major aspect, but
yeah, I
But
don't know.
It's a
So
system. It all works together.
I'm not convinced, but I think it's an interesting idea, the convection currents. I would like to see someone measure them. But anyway, moving on.
Moving on.
Kiki, when you're without your monogamous life partner, do you ever feel sad? You're supposed to say yes. Just the answer is yes.
I figured if I didn't say anything, I wouldn't get in trouble.
I'm sure you do. If you were without that individual for an extended period of time,
yeah,
you might get a little bummed out. You might not find the same lust for life that you would normally without them, perhaps.
Yeah,
just a thought.
You miss your other.
Yes. So that's also true for cichlid fish. The University of Burgundy looked at pair bonded individuals, which in this case, the wild convict cichlid fish mate monogamously. After mating, when the female produces eggs, the males hang out and protect her and the eggs. So they form a very solid bond. After the eggs hatch, the young are protected by both parents. They continue to hang out together. And so to learn more about the bonds that they forge, the researchers wanted to look at a two-part experiment to see how much they were attached to one another. In the first part of the experiment, the researchers separated a large tank into 3 sections. They put a female in the middle and a male on either side. The team watched to see which one she demonstrated a preference for by quote unquote cozying up to one or the other. So she showed a clear preference for one male or the other. The researchers then put one of the males in with the female and allowed them to mate. So it might have been the one she preferred. It might not have been. The report showed that females who were allowed to mate with their preferred choice spawned faster, had more offspring, and took better care of them compared to those paired with a rejected mate. So that you could argue generally happier and therefore healthier, maybe less stressed, which could lead to all these physiological items. We don't know. But regardless, greater reproductive success as a result of getting with the male she preferred. Now, the part about this study I really found interesting was the second part of the experiment. In the second part, researchers trained the females to recognize the difference between a box containing food and one that was empty. Then they introduced a new box, which required investigation to see if there was food inside. So they didn't know. Could be box half full, box half empty, right? The level of interest they showed in investigating the new box was considered a marker of mood, which you can take or leave that. But basically, is she feeling optimistic or pessimistic. She feeling like there's probably food in there, or there's probably not food in there, or I want to go see what's in there, or I don't want to go see what's in there. So in these binary terms, looking at that as happy or sad, optimistic or pessimistic. They found that when her chosen mate was present in the tank with her, she expressed more interest in checking out the new box than if the rejected male was with her. The researchers claim this is an example of pessimistic bias, which shows that the females do become gloomier when separated from their desired mate. So, to kind of try to draw a human analogy to this, which is always problematic when you're talking about animal studies, but just thinking about what this kind of reminded me of is if I went to a party where I knew no one, and if I had my significant other with me, I would be so much more likely to talk to people. Maybe I'll find a friend here today. If I was alone, or if I was people I didn't care for too much, I might be a little more hesitant to go out there and try stuff. I probably wouldn't feel as supported, right? But also, if you think about also made me think about if you've ever been to a natural history museum where there are weird experiments you can try out that are like mounted on the wall. If you're walking through that museum by yourself, I mean, I'm not, but I feel like the average person might be less likely to try everything unless they were with people and they're going like, oh, hey, check this out. So I kind of, if anything, it just felt to me, it sounded to me like having a support, having a familiar being in the space with you is beneficial to exploration, trying things out. I don't know. That's not the intention of the study, but that's kind of what made me that's what I thought about when I was reading this. So, yeah. Kiki, are you talking? We can't hear you.
Sorry, I was wondering why you weren't responding to me. I had muted myself so I could drink water, but
there you go.
no. Now, my first thought was that this how could these researchers equate this with positivity or gloominess? I mean, this is
Yeah.
putting an emotional spin on a survival situation.
Yes.
Number 1, you have mate choice. The female is choosing a mate for reasons that we cannot begin to fathom at this point in time. Potentially, there is a certain matching of traits that would mean that the female fish would feel that preferred mate would be more protective of young, a better provider. I don't, depending on the ecology of these cichlids, um, there are factors about that preferred male that are better
Yep.
than the not preferred male. The rejected male, she's already rejected him. He can just go away, and his presence has already been deemed unhelpful by her. You put them in a situation where, as you said, it could be that with the preferred male, the female feels less stress because there is a sharing of responsibilities when it comes to predator avoidance and protection, and as I said, providing of resources. So the final question when you get into these different boxes is she's on her own. She's on her own. She has to watch her own back. She is not going to be exploring like is not happy go lucky. It's just she is in a survival situation. When she's with the preferred male, that means once again, she's in a situation where she feels, not even just feels, but she knows that there is another individual there that will share responsibilities with her.
Absolutely.
Lowering stress levels. Lowering stress levels increases explorative behaviors. Stressed animals across the board are not the ones going and exploring their environment. So this to me, has nothing to do with depression, happiness, gloominess. This is stress.
Yeah. Yeah, absolutely. And so I think that's why I was thinking about the party where you know no one, right? Is because your partner is your stress reducer. They are your safety net. If you can't find anyone else to talk to, you always have them. They will help you start conversations. They will share the stress and burden of this stressful scenario. And so when you do that by yourself, it's a lot harder. And I feel like that's exactly what this is. Okay, I'm going to try to go in this box, but if I don't find anything and that's wasted effort, I have somebody else to help me find more food.
Yes.
Yeah, absolutely. So I think
I can watch for a predator while my partner goes and scans the buffet table.
Absolutely. Absolutely. So yeah, I totally agree with you. I think that this is a very interesting study that shows that monogamous pairing is intentional, right? Which we already know, but definitely that then after the fact, there's benefits to being with the intended target there, and that there's a reassurance. I would argue that's kind of the emotional attachment that you could put on this, is there's benefit to reassurance in this case.
Right.
So yeah, I think them saying it's pessimistic because she's sad is a
Yeah,
little too far.
I think, this is potentially animal behavior jargon, not potentially this is not representing what we think of when we think of pessimistic bias.
Mm-hmm.
Um, they say this indicates a negative affective state, which I would agree with that statement,
Mm-hmm. Mm-hmm.
because it's not the affect of the animal is in the more negative direction than the more positive direction. And so
Right.
that I think is more accurate of a statement, but putting pessimistic bias on it, it's like,
Yeah,
those be human words.
absolutely. Yeah.
There's not you can't say that a fish is a pessimist. Psh, jeez.
And Hot Rod in the chat room asked a really good question. Why is this from the female side of the couple? We should see what happens on the other side. Do the male fish care when separated from their chosen female?
Very good question.
Or do they not care and so it doesn't really matter, which I think is actually probably the possibility. But after they've been paired, if you separate them, is there an issue? Yeah, it's a good question.
Yeah, very interesting. I have a feeling it's because mate choice is on the female side of things, and not so. It's like the male goes, "Oh, you picked me, awesome."
But there could still be negative effects if you separate them after that because they are
Yeah.
monogamous. So yeah, I think it would be interesting to see. But yeah, there we go.
Very fascinating. Oh,
Mhm.
fish and their moods. I hope you're not getting moody, because we're going to take a quick break. It's time for us to say a few things. We'll be back in just a few more moments with more This Week in Science, and hope that you will stay tuned for sneezing fish. I mean, sneezing, not fish, sneezing plants. We're just adding all sorts of things. We got hyenas and dogs also coming up in the second half. So please stay tuned for more This Week in Science.
Can't explain things you've heard with more than intuition. A lot of research shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need.
I hope everyone out there is wearing their goggles. Are you enjoying this episode of TWIS? I really hope that you are. We're so glad to be with you once again as we bring you TWIS every week of the year, except for maybe a break every now and again, but pretty much every week of the year. It's a long running show. And we need your support. We would love to count on you for all kinds of support. And one of the ways that you can support us is by heading over to twis.org. If you click on the links at twis.org, they will take you to a cornucopia, a veritable cornucopia of places for supporting TWIS. First up, at twis.org, click on the subscribe button. Takes you to the big three: Google Play, iTunes, and YouTube to subscribe to This Week in Science if you have not already done so. Or you can tell somebody else to do this. If you're already subscribed or you just enjoy us every once in a while, you can buy TWIS goodies. We have a store. Our merchandise is at zazzle.com/thisweekinscience. You can click on the Zazzle link and find TWIS t-shirts, TWIS polo shirts, tote bags, pillows, wrapping paper, phone covers, all sorts of things with the TWIS logo and art from Blair's Animal Corner calendars of years past. A portion of the proceeds supports This Week in Science. Back at twis.org, you can also click on our Patreon link. The Patreon link takes you to our Patreon community, which is where you can become a patron. Click on that red button and support us in an ongoing fashion. If you click on the $10 a month button, that's $10 a month, we'll send you a few little goodies and we will thank you by name at the end of the show for supporting This Week in Science. That's right. Photon support. Be the light in our darkness. Help us keep bringing you TWIS. Back at twis.org, we also have a yellow donate button that uses PayPal to allow you to donate one time or in a recurring fashion on the basis of your abilities. Either way, anyway, we appreciate you listening to TWIS, being a part of our show and continuing to bring us into your lives week after week. And this show, all of it, you support us. We really could not do this without you.
Can't explain the things you've heard with more than intuition. A line of reason shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
And we're back. You're listening to This Week in Science. What time is it, Kiki?
It is time for that segment of the show called This Weekend, What Has Science Done For Me Lately? What has science done? Laura Mumma wrote to us on our Facebook page, sent us a message there, said, "Thank you for your wonderful show. When I discovered it by accident on a radio station, I began to tune your show on my school bus. You must listen somewhere around the Davis, California area. Your show has helped me spread the joy of science to children while transporting children around my school district. Many of the children I transport are not in programs geared toward teaching STEM. My current summer school bus radio does not pick up the radio station you are broadcasting on weekly, but I will be overcoming this problem and plan to replay your podcasts on my bus's archaic equipment for my kids. I just wanted you guys to know your show has led to children, often discouraged openly from developing an interest in science or math, to discussing and even researching on their own science subjects that sparked their curiosity. Thank you so much for your show, Laura Mumma."
Oh,
Laura, thank you for listening to TWIS in the first place. I love that you tuned your school bus radio to the station, and then you were able to hear us. And then from there on, you've been listening, and now you're going to do what you can to bring the podcast to your school bus, even though it has that archaic equipment. I mean, so many levels of this are fantastic. The level of the radio technology that allowed This Week in Science to come to your bus, and also the fact that your children are listening, that they're able to listen, and that it is possibly sparking curiosity in some of them to investigate things on their own. And thank you for letting us know about this experience that you're having. It's wonderful. Thank you. Everyone out there, if you would like to send us a letter about what science has done for you lately, send me an email, Kirsten@thisweekinscience.com, or leave us a message on our Facebook page. We would love to hear from you. All right, Blair,
Yes.
tell me a story.
Oh my
Please.
goodness. What do you love about dogs? I could go on and on and on, but what do you love about dogs? I know you have cats, but what do you love about dogs?
I love that they're so expressive.
Yeah.
A friend of mine has a dog who every time I come over, she stomps her little feet and then she raises her lips and shows me her teeth and her eyebrows go up and her ears go up and she's just and there's so much excitement.
Yes.
She smiles at me.
Oh my goodness.
It's
Yes.
amazing.
So we already know dogs have evolved a bunch of interesting traits to be able to connect with us, sometimes more so than with each other. They're very good at creating eye contact. Their entire skeletal system is set up so that their head is raised up instead of flat backed straight to their head like wolves. And a lot of this has to do with the fact that they are tuned into humans. They have evolved for 30,000 years. Some studies suggest maybe 50 or 60 or 70,000 years, depending. Someday, maybe we'll figure it out, that they have been living with us along this period of evolutionary time. Depending how you want to look at it, either we have selected for dogs that are tuned into us, or they have adapted to better tune into humans since we were an excellent source of food and shelter and companionship. So, either way, either we formed them or they adapted to us on their own. It's, kind of potato, potato, but still
Right.
an interesting question of the initial motivation for this change. But a US UK team of researchers recently wanted to look at the face musculature of wolves and dogs. This is right down to what you were talking about, Kiki. The fact that they can make these facial expressions
Mhm.
that we can read. We can tell when a dog is in pain. We can tell when they're happy to see us. We can tell when they're sad that they messed up and we're telling them off. So that right there is something. And right now, Kiki's showing a picture of a dog who has these adorable puppy dog eyes, even though it is an adult. And then they look up at you, and one eyebrow is kind of going up, and they're making this intense eye contact. You can even see whites of the eyes on the sides, which isn't true for wolves a lot of the time. And in that moment, even looking at those photos, my heart is melting actively. And that right there is what these researchers were looking at. They were looking at muscles that control movements of the face near the eyes. And researchers suspect that the muscle's presence helps dogs make what they are calling here a sad-eyed face. I don't know if that's what I would call it necessarily. Technically, this is called a pedomorphic facial expression. Pedomorphic as in of a baby. So this is adults retaining features that are commonly associated with young animals. And this is usually partially what we consider kind of like the cuteness measurement.
Mhm.
So when animals, I think this is one of the reasons people love pandas, for example, is that they have faces that look somehow like a teddy bear, and teddy bears are designed to look like baby bears. And so there's this compulsion to think that animal is really cute and want to snuggle it, and maybe related to a conversation we had a few weeks ago, take a bite out of it.
Rawr, let me eat the babies.
Go ahead, listen back if you want to hear about why you sometimes want to take a bite out of a baby's toe. Very interesting study. But that is what this is about: is an animal that has young characteristics that are viewed as cute. This is actually something that we have unknowingly potentially selected for because we think it's so cute. We like it so much. So this expression in particular, they were looking at these muscles around their eyes, were allowed them to raise the skin above the eyes closer to the bridge of the nose. So it's that like eyebrow up muscle. I can't do it, but it's this one right here. This expression is considered sad-eyed or puppy dog eyes. An earlier study showed that dogs that exhibited this expression more often in a shelter were more likely to be adopted. So right there in modern day, that's selection. If
Yep.
there is a shelter that is unfortunately euthanizing individuals that are not being released and those animals are not fixed, then there's pressure there. But otherwise, back in the day before we were spaying or neutering animals, if those are the animals that we took home and took care of, then they were the ones that would get to reproduce, right? So to test this hypothesis, researchers took the heads of dead dogs and dead wolves, and they dissected them to identify muscles. I know it sounds very sad, but this is how science is done. It's how the sausage is made. Sorry, guys. They did not have a lot of samples. It was a very small sample size, 4 wolves, 6 dogs. The results are preliminary, and they recognize that because it was a small sample set. For the most part, there were very little differences in the facial muscles, but the 2 sets of muscles they found differences in, one was called the retractor anguli oculi lateralis, pulls the side of the eyes towards the ears. This was present in wolves, some wolves, and all dogs, but was more developed in dogs. So this has to do with the perking up of the ears with the, huh? You're home!
Mhm.
The main finding, though, was this angular oculi medialis muscle, LAOM, which is nearly absent in wolves. And this is the one that pulls the inner side of the eye, that inner corner up, which is that, huh? That's my technical term. That's the huh muscle.
The what?
Huh? You talking to
What?
me? Biscuits?
Yeah.
Right? So there's the research keeps saying this is a sad expression. And I was listening to a comedy podcast today that mentioned that this was like the wolves manipulating humans. I think that's too much. I think really all it is creating a connection to the human. Looking somebody right in the eye and changing expressions along with input from a human. I really think that's what it's about, is just recognizing a connection and that they're listening to you, they acknowledge you, and they're going to change their behavior based on your behavior.
I think also the making eye contact is very important,
Mhm.
and in being able to open the eyes more widely than wolves because of that upper eye muscle, the LAO muscle,
Right.
that would allow more open-eyed appearance.
Right. Which is a trait of dogs versus wolves.
Yes.
Absolutely. Yeah.
It's a
Yeah.
trait of dogs versus wolves, and it's also a trait that, like we said, it's this paedomorphia,
Mhm.
where the animal has bigger eyes. A baby has bigger eyes. It has that childlike
Mhm.
essence.
Mhm.
Um, yeah, you see more of the eye, and it makes more eye contact, and it's kind of a super normal stimulus.
Yeah, absolutely. Which leads to the one kind of last asterisk on this study, which the researchers acknowledge that there most likely is some genetic selection happening here for the ability to make eye contact and make expressions that humans can pick up
Mhm.
on. However, mu-
Communication.
muscles can change in size based on frequency of use.
Yeah. Okay.
So, if a dog is spending its entire life moving those muscles in response to humans, they could end up bigger for that reason as well.
Mhm.
So the way to test that would be to take a wolf and
Puppies.
raise, yeah, a wolf puppy, raise it around humans, but then of course their brain is also just not as set up to acknowledge humans. So there might not be a perfect test to figure that out. Not that we really need to know.
Well,
Mostly I think,
you could look at the size of the muscles in the pups.
oh yes, that's true.
Yeah.
Yeah, that would
You
be a
could do
great
that.
place to start. So considering they're pretty much mostly absent in the adult wolf skulls, is that from lack of use? Or did they start with nothing? Yeah, it's a great question. So I think you're right. I think that's the next step. And ultimately, this is just an example of how dogs are extremely well equipped to respond to human stimuli, whether we chose that for them or whether they evolved into that niche of human companion. I think that's the part that's really interesting and potentially impossible to know.
Yeah. Yeah, but it is fascinating. I
Yeah.
from anecdotal personal experience, I do know that the only reason I can cock my right eyebrow is because I held my eyebrow down as a child and looked into the mirror and raised my
Really?
eyebrows, and I only
Oh,
did it on one side, I didn't do it equally on the other side, so I'm not as able I'm unable to do that with my left eyebrow the way that I can with my right. I trained myself asymmetrically, but I trained myself.
wow.
Mhm.
Ooh, I can learn. All right, I know
You
what
can
I'm gonna do
learn.
this weekend.
You too can learn. Just hold your It was like eyebrow push-ups.
Ugh, ooh, that's nope. I can't do it. Kiki, you got some more science for me?
I do. I have another story here about let's move from dogs to hyenas.
Ooh.
Yeah. So historically, if you are wandering around America, you don't really run into hyenas except at possibly a zoo. But really, hyenas are not prevalent in the Americas. Blair, as a zoologist, where do we find hyenas?
Africa.
Yes, in Africa. Historically, ancient hyena species, the extinct genus Chasmoporthetes, which is also known as, or could be Chasmoporthetes if the CH is a K,
Mm.
Chasmoporthetes. It's known as the running hyena. This was a really long legged hyena, very long legs. So they think that this hyena would have sprinted and run
Hmm.
very quickly. Um, these hyenas, teeth from them have been discovered in America. And they've also been discovered in Asia. So we
Mhm.
know that long, long ago, there were hyenas in the Americas, down in Mexico, in the southern United States. We have hyena fossils in the southern US and Mexico. Hyenas. It's like, okay, they're not here now, but they used to be. How did they get here? Of course, the hypothesis that pops up is ancient ice land bridge, the ice age, which would have reduced sea levels and led to the Bering Strait, the land bridge that connected Asia to the Americas. But there's never been any evidence for it. Researchers, however, finding teeth that have been kicking around in a
Hmm.
drawer for many
Hmm.
years, as so often happens. Um, these teeth were at the Canadian Museum of Nature in Ottawa. They had been found, and there were references to them in an unpublished manuscript by an archaeologist named Brenda Beebe. There was a paleontologist who decided that he needed to named Sang, who decided that he needed to find these teeth and check them out because they were potentially dug up in a place called Old Crow Basin in the Yukon. Now, if these fossils were indeed hyena fossils, it would give a pin in the map for that bridge between Mongolia and
Hmm.
Mexico.
How
Well,
do
they
we
dug
know
them up.
they're hyena teeth?
They match the teeth. So there's a very specific tooth look of the
Hmm.
hyena teeth, and so these teeth,
Interesting.
they are a match for the teeth of this extinct hyena species. It was a
Interesting.
tooth found in 1977, one
Hmm.
of only 2 hyena fossils found in the Arctic Circle.
Yikes.
So the Pleistocene ice age resulted in hyenas traveling to the Americas. And the teeth, because of where they were located in this basin, can be dated exactly to that Pleistocene ice age between 850,000 and 1.4 million years ago. Hyenas in the Arctic.
It's far out.
It's far out, man.
Literally far out.
Isn't that neat? Yeah, and not just hyenas, but rapidly running hyenas that would have been terrifying.
Yeah.
I can say, thanks, I wasn't there. It's good.
Yikes.
Yeah, yikes. I've got some more stories.
Yeah.
I'm gonna kind of roll right through them right now. You wanna talk about some information?
Yeah. What
Yeah,
kind of information? You got blackmail,
I got
stock tips,
I got some
animal facts.
good information to you. I mean, I might not wanna give it to you though, because, if I don't wanna give it to you, maybe you might want it more.
Yeah, that
Wow.
checks out for sure. If somebody's like, I have a secret.
Mhm.
Oh,
And
I want to know that secret.
how much would you be willing to pay for this information?
Depends on the category of information.
It does. But some researchers some researchers at Berkeley at the Haas School of Business took people, stuck them in an fMRI machine, functional magnetic imaging machine, and had them play gambling games. By looking at the brain and the areas of the brain that were activated while these games were being played, what they were able to ask was, first, could they reconcile the economic and psychological views of curiosity, or why do people seek information? And second, what does curiosity look like inside the brain? The end result is pretty much that the subjects make rational choices based on economic value of information, and they were able to parse this because of the gambling game where, the stakes would get higher, but the decisions they should make should only be related to the cards in their hand or what the gambling the specific situation that they're gambling for. But what they determined was that people tended to overvalue information, especially in higher valued lotteries. Higher stakes increased people's curiosity, even when, like I said, that information shouldn't have had any effect on their decisions on whether or not to play. And so they could see what was happening in the brain and what they call the curiosity that was happening. They found regions of the brain that are known to be involved in valuation, striatum, ventromedial prefrontal cortex, and these are also activated by food, money, and drugs. These are dopamine producing reward areas. So, information as we scroll through our social media feeds,
That's exactly what I was thinking about. Yeah.
as we look at the internet and scan for news, as we
Yeah.
spend our time online and we talk about digital addictions, they really are. They are information is actively stimulating the areas of the brain that are known to be involved in reward and addiction. The researcher the researchers say we can look into the brain and tell how much someone wants a piece of information and then translate that brain activity into monetary amounts. The way our brains respond to the anticipation of a pleasurable reward is an important reason why people are susceptible to clickbait. Just like
Mhm.
junk food, this might be a situation where previously adaptive mechanisms get exploited now that we have unprecedented access to novel curiosities.
That's exactly what I was thinking about was scrolling through social media, but also how I'm sure this has happened to most of the people listening to this show because we are all interested in science news, so hungry for information and learning of some sort. But you'll Google a thing and that'll mention a thing that then you have to click on or Google that will then mention a thing that then you have to click on or Google, and you fall
Mhm.
down this rabbit hole before you know it, where, I might click on the 10 cutest dog memes of the day, and then it'll say, since you like this, you might want to see the latest research about dog eyeballs, and I'll click on that. And then so the internet, a lot of analytics have figured out how to recognize like information, which I think is exactly what this is about. What is just related enough that it will continue the clicking? And just like we've talked about with social media, they have figured out the exact ratio of good feelings to boring or bad for you to keep going. And that's exactly how
Scrolling.
gambling works.
Yes. How long will you keep pulling the lever
Yes.
on the machine? Yes.
Gosh.
How long will you continue doing? One thing
Yikes.
that I additionally thought was very interesting here is they say that the brain turns information, whether it's turns information into a common code that is the same whether it is money or food or drugs or information. It's that the brain has a methodology of valuation, and there is a common code within the brain underlying all of that.
There
So
you
that I
go.
think also is a very interesting insight into how the brain responds to things in the environment.
Hmm.
Coded information, money, drugs,
Interesting.
things. Yes.
Yikes.
Yeah.
I'm hungry for information
You are?
about sneezing plants.
Achoo! Excuse me.
Bless you. Oh, I'm sorry. How rude of me. I didn't say bless you.
No, no, not at all. So, seriously, plants can sneeze. Did you have any idea?
No, and I still don't believe it. Please tell
Well,
me more.
not really a sneeze in the traditional sense of a sneeze
I
because, of
knew
course,
it.
plants don't have lungs. They're not having their nasal passages tickled by particulate matter. Or whatever. Sneezes are different in the plant world. But there is a study in the Journal of the Royal Society Interface looking at a phenomenon which has been described for years, which is called uh, surface tension catapult. Plants have hydrophobic surfaces, so they don't attract water to stick to them. If you look at the leaves of plants, the water balls up and beads up into droplets. In very extremely water repellent, super hydrophobic surfaces like wheat, certain plants, these drops, when they hit a certain they hit each other or they touch the plant, that the drops can actually get catapulted off the surface of the plant because they're being repelled. The surface of the plant wants to repel them. It's not being attracted, so it's like, boom, trampoline, get out of here. These drops can jump several millimeters, which is potentially high enough to escape the boundary layer surrounding the plant, which is just a layer of still air. And if it escapes that boundary layer, it can be lofted on the breeze to nearby plants. Now, that brings into account this more recent study in which the idea is if plants have pathogens, fungal spores perhaps, that are in existence on the surface of those leaves, those spores could get encapsulated in these droplets of water. The catapult effect could move the pathogen laden drops of water onto neighboring plants, spreading disease, just like a sneeze.
That is like a sneeze.
Yep. Isn't that cool?
Oh boy. Plants,
Yeah.
man. They're just like us.
They're just like us, but different.
They talk to each other. They run away from adverse situations. They sneeze.
They sneeze. Plants sneeze. Yeah, so this
Just like
is
us.
a new aspect of plant biology that needs to be looked at for pathogenal control. How can we take this into account, this water
Mhm.
movement, in trying to keep down certain pathogens that can dramatically influence the health of our crop plants, especially.
Ooh, I know. Install a sneeze guard like on a salad bar, right? There you go. Fix it.
Totally will work. That's
Yeah.
totally good.
Just do that in labs at least when you're propagating plants. You
Yeah.
can do that.
And quickly, very quickly, mind control
Uh-oh.
is coming. Researchers at Carnegie Mellon, these engineers, have improved the accuracy of non-invasive brain-computer interfaces,
Mm.
allowing people to learn how to control a robotic arm more quickly than usual using these non-invasive brain control interfaces, and also to control the arm more accurately so that the arm tracks the movement of the thought uh, in a smoother fashion. So accuracy, efficiency, and training are improved significantly in this new methodology that the researchers are using. And it's important because we don't always want to be putting electrodes in people's heads.
So what was it?
Right?
Was it like a
Non-invasive.
little earpiece or something?
In this particular case, it's probably more of EEG style h- h- electrodes on the outside of the
Yeah.
brain, picking up that
A big
gen
science fiction-y hat.
Yeah, more of a science fiction-y hat in this case. Exactly.
But, you know, if
Um,
they got really good at it, you could put it maybe, like, behind your ear on the skin right there, and then you could have
mhm.
a prosthetic and okay. Neat.
Yeah. I mean,
That's very cool.
there are some very sleek, brain computer interface headsets that are available for gaming and, meditation and, kind of neural feedback loop training, and they're sleek and they don't look too they're not too, big and bulky. They're nice. And the idea though is that when you're getting the information from the outside of the brain, it's very noisy.
Mm,
And how do you get rid of all the background noise? The researchers really the step forward is in getting rid of the background noise
mhm.
in this case.
So, you could potentially use this, I think, to get the technology really, really, really good.
Mhm.
Get the conversation between the headpiece and the prosthetic, get prosthetics to be really good. And then you could get to the point where you go, okay, now we want to install this in somebody's brain. But I like having this non permanent option when the technology isn't perfect yet.
My final story is speaking of technology that's not perfect, Alexa, I'm
Oh,
having a heart attack.
oh no.
Well, those home devices like Alexa and the Google device, these things that are listening to our lives, taking our pizza orders and those
Yeah, she
yeah,
hears, I, I'll order you a coffee, black.
that's right. Exactly.
No, that's not what I said.
That's not what I said. Well, these devices are listening in on our lives all the time because they're waiting to hear the words that they need to follow our directions. So, researchers taking this into account determined that they could train a system, create an app that could be installed either in a phone or in Alexa or something similar that could listen for a particular type of breathing that occurs when someone is having a heart attack in about 50% of cases. And it identifies this breathing about 97% of the time, and in, their test cases, they do need to test it on a larger set of 911 calls in which people had this breathing. That's how they tested it for the first place. In certain situations, there was, 0% of false positives. So and what that means is and it was a very low, rate otherwise for their false positives, which means that they weren't making this device, their app, isn't making mistakes on
Hmm.
thinking that the breathing is a heart attack when it's not and calling the emergency services on accident. But this could be something that if somebody is potentially at risk for a heart attack, at a certain age, or
Mhm.
you have metabolic disease or cardiovascular disease, that you could set up once this is all put together, you could set up, have your Alexa or your phone listening while you sleep or other times, and call 911 for you when you're not able to.
You know what else you could ask it to do is to listen for sleep apnea and report back to you the next day.
See, something like that would be cool too. You wouldn't
Yeah.
want it to call 911 for the sleep apnea,
No.
but yeah, to know how often you weren't
Yeah.
breathing is pretty
Alexa, what
important.
time is it? It's 6:00 a.m. and you stopped breathing 4 times last night.
I don't need to know.
I mean, it might be helpful.
It might be helpful. Hey, Blair, give me a story about dinosaurs.
Yeah, you know what else might be helpful? To know if dinosaurs could smell well. This is University of College of Dublin. They looked at the study of the olfactory bulb ratio in modern birds and used that to predict possible olfactory strength in dinosaurs. The olfactory bulb in most modern animals correlates with the strength of their sense of smell relative to the rest of the brain. Is the olfactory bulb ratio, and that's how they decide. The size of the olfactory bulb is related to the number of smell receptor genes in the DNA of a given animal, so it stands to reason that that would be a good measure. So taken together, it's called the OR, the olfactory repertoire. Olfactory repertoire. In this new effort, researchers used the OR of modern birds and an alligator to estimate the olfactory ability of dinosaurs. The brains of dinosaurs do not fossilize naturally, soft tissue, so there are no examples of olfactory burbs
Burbs. That's
from dinosaurs
correct
to look
use.
at. But there are endocasts, brain imprints on the inside of skulls that they can use. So from that, they can look at the alligators and the birds, and together with all of that information, estimate the size of the olfactory bulb in dinosaurs. They then gathered the OR data on the birds and the alligator and put that all together to come up with estimates for the strength of the sense of smell of dinosaurs. They found that for many of the larger dinosaurs, they had what is likely to be a very good sense of smell. That includes the T-Rex, who we have gone back and forth on saying whether they were hunters or scavengers. I personally am all in on the scavenger hypothesis, and this helps that. Think about your vultures. They have an excellent sense of smell. So they say the study does not yet clear up whether the T-Rex was a scavenger or not, but I'm saying I'm all in on scavenger. But regardless, dinosaurs appear to have had a good sense of smell.
Awesome. Which it totally stands to reason that, because birds do too, even though people didn't know that for a very long time.
I know. I was taught that birds can't smell.
And they can very well. Yes.
They can.
Yep, it's just because that pesky olfactory bulb was on the bottom of the brain and kept falling off when researchers would take the brain out of the bird's head, and then they were like, "They don't have an olfactory bulb. Where's all the olfactory neurons? Where do they go? I don't know. They must not be able to smell," as opposed to realizing that they had separated and they just missed part of the brain.
That is one of my favorite stories about science ever.
Mine too.
It's favorite and also frustrating, but definitely favorite at the same time.
Yeah. Depends on what birds you're looking at, how you're looking at them. Yeah.
It plumb fell off. Whoops.
Yeah, I'm sure they weren't looking at vulture brains in those situations.
No, because they knew vultures could smell.
Yeah. Oh, we have done it. We've come to the end of our show. We did it. Good job, Blair.
Yeah, good job, Kiki.
What? I may not be here next week.
Oh no.
Even though my answer to Blair's question, with my silence of how I feel when I'm away from my partner, we have a
he doesn't listen
significant
to the show, right? So it's fine.
No, he never listens. We have a significant anniversary coming up, so I may not be here next Wednesday, but there will be people here keeping the show going for you. I would love to say thank you for listening. Shout outs to our wonderful volunteers who help out. Fada, thank you for doing double show notes this week. That was some good duty that you did, helping with the social media and getting more stories out this week because of our extra show from the Interplanetary Festival. That is so much appreciated. Identity 4 also, thank you for recording the audio from the weekend and for always recording the audio for this show. For people who were able to watch us this weekend, thanks for watching while we tried to do the live thing in Santa Fe, which turned out pretty incredible. And I would love to say thank you to our Patreon sponsors. Thank you, Paul Disney, Richard Onimus, Ed Dyer, Ed Andy Gross, Stu Pollock, Philip Shane, Ken Hayes, Harrison Prather, Charlene Henry, Joshua Fury, Steve DeBell, Alex Wilson, Tony Steele, Craig Landon, Mark Mazzaros, Jack, Matthew Litwin, Jason Roberts, Bill K, Bob Calder, Time Jumper 319, Eric Knapp, Richard Brian Condren, Dave Neighbor, John Gridley, David Williams, Corinne Benton, Adam LaJoy, Sarah Chavis, Rodney, Tiffany Boyd, John Bertram, Mountain Sloth, Seth Ogradney, Stephen Albaran, John Ratnaswamy, Dave Friedel, Daryl Myshak, Andrew Swanson, Paul Ronovich, Sue Doster, Dave Wilkinson, Ben Bignell, Richard Porter, Noodles, Kevin Reardon, Christoph Zuknarek, Ashish Pants, Ulysses Adkins, Art. Hi, hit my microphone. Artyom, Rick Ramus, Paul, John McKee, Jason Olds, Brian Carrington, Christopher Dreyer, Lisa Slazuski, Jim Drapeau, Greg Riley, Sean Lamb, Ben Rothick, Steve Leisman, Kurt Larson, Rudy Garcia, Marjorie, Gary S., Robert, Greg Briggs, Brendan Minish, Christopher Rappin, Flying Out, Aaron Luthen, Matt Sutter, Mark Hessenflow, Kevin Parachan, Byron Lee, and E.O. Thank you for your support on Patreon. If any of you out there, if you want to support us on Patreon, you can find information at TWIS.org. Also, remember that you can help us out by telling your friends about TWIS. On next week's show, it's a mystery. We were going to have an interview, but I'm not going to be there. But maybe Blair and Justin want to do the interview without me. I don't know. We'll see what happens. But regardless, the show will go on as it does, 8 p.m. Pacific time, Wednesday night. You can join our chat room if you watch live at twist.org/live or on our YouTube channel. But if you can't make it live, that's okay because the show is archived and you will be able to watch it again on YouTube or find it at twist.org.
Thank you for enjoying the show. TWIS is also available as a podcast, for your ear holes. Just search for This Week in Science in iTunes. You can look for TWIS for Droid and Android or anything Apple Marketplace related. Just go ahead and search TWIS or This Week in Science.
And for more information on anything you heard tonight on the show notes are going to be available on our YouTube page with the description in a day or so, and also at twist.org. You can find the show page and there are all the notes, and you can also make comments and start conversations with us and the other listeners at our website on those pages.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twisminion@gmail.com, or me, Blair, at blairbaz@twis.org. Be sure to put TWIS, TWIS, somewhere in your subject line, or your email will surely be spam filtered into the deepest voids of space. You can also ping us on the Twitter where we are at TWIS Science, at Dr. Kiki, at Jackson Fly, and at Blair's Menagerie. If you want to see quite the rant about peppers in Santa Fe, you can also check out at Shouty Blair. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, something that amusing that you want to send our way, please let us know.
And we'll be back again next week. And we hope that you will join us once again for more great science news.
And if you've learned anything at all from the show tonight, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just get understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma. Got the eye. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 This Week in 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 Science.
The show is over. Let's play in Portland because it's in Portland. Important,
Yes.
important.
In Portland.
In Portland. Yeah. Hey, everyone. It's the after show right now. We have switched over to the more casual part of the show. And I've realized, I wrote it in the chat room, we should make a music video.
Yes, we should.
Wouldn't that be fun?
Mm-hmm.
I should
Kind of, we could replace that old, like, science one.
Yeah. Yes. As our theme video. Yes. We need to do a new one of those also.
Yes.
We should. The kind of descriptive video needs to be updated on our YouTube page. I mean, that is if we are going to continue to use YouTube. I got to figure out this thing.
Yeah. Yeah, I would love to do a whole, like, press packet update where we could do a video, we could get more pictures, because we just have that one really good picture of the three of us we use a lot, but we could probably use another one.
Yeah. I mean, update it with more wrinkles.
I mean, you know, with the right lighting.
With the right lighting, it'll be fine.
Yeah.
Fantastic.
Yeah, but we could yeah, I think it would be good to do some of that. And I mean, the other thing that, like, when I applied to Sketchfest, I haven't ever used one before, but they asked for a demo reel.
What?
I know. I never do one. I just give them a link to our latest live show. Like, here, watch us do what you're hiring us to do. There you go.
Yeah, we can do a live show for you.
Yeah. But I think a demo reel wouldn't be the worst thing.
It wouldn't.
So it wouldn't. That's something that we could potentially do. I would be more than happy to fly to Portland and spend a weekend on this stuff with you.
Yeah, that would be fun.
I'd be totally down.
Yeah, editing a demo reel, though, I mean,
Yeah.
I could probably hire somebody to do that, download a bunch of YouTube videos from YouTube and clip them together.
Yeah, it would be great if it would be like, this is what TWIS is. Here's
Oh,
some
but we kind
clips
of
of
have that.
Kiki. Here's some clips of Justin. Here's some clips of me.
We
Do
kind
we
of
have
have that, though, with the video that Philip Shane made for us.
Oh, yeah.
'Cause that kinda it has live show stuff in it, and it has, like, an interview with me walking around New York, and
Mhm. Mhm.
yeah, it's got
That's true.
interviewee
I
stuff.
forgot about that.
Yeah.
Hmm.
Not a demo reel per se, but it's shorter than a normal live show, and
Yeah. Yeah.
could be good.
Musings. I don't know.
Yeah. Yeah, all the things. But we should making of things is good. I mean, it's a matter of time and
Yes.
energy and
Always.
yeah, and, it's kind of what you get used to. I was wondering today whether living in Portland allows me to be more tired more often and to just say, "It's quiet. I'm tired. I'm not gonna do that work right now. I'm tired." Or if I lived someplace like San Francisco or New York even, if I would be just constantly go, 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 and
Mm.
just if it would be the energy of the city that would keep me doing more often and not allowing myself to kind of fall into the rhythm of the calmness that Portland has.
That's interesting.
It's just
Wow.
just a musing that I had today. I was
Hmm.
musing a little bit. But, I've been thinking a lot about Meow Wolf
Mhm.
since Meow Wolf we watched the documentary
Oh, yeah?
last night, and it's a great documentary. Um, I mean, I left Meow Wolf mind blown, inspired, so excited, and my Kai was so into it, like, we were all so thrilled, it was amazing, and never seen anything like it, never experienced anything like it. Then we watched the documentary, and even more so, I'm just like, "I wanna run away, and I'm not running away from home to join the circus, I'm running away from home to join Meow Wolf."
Yes. Yes. Was it on any platforms, or did you just YouTube it, or
I think it's on, might be on Amazon,
Okay, great.
something like that, yeah.
Can
It is out
do.
there. It's out there,
Oh
and I'm
my
not
gosh.
considering moving. I do love my life in Portland. It just there is constantly this consideration of, should I be doing more? Could I be doing more? What do I
Yeah.
want? What more do I want to be doing? What is the state of my life that keeps me content? You know? All of us, we can work really hard for a little bit on something, but
Mhm.
do you wanna work really hard all the time forever? No.
Yeah. No.
No, burns you out after a while. So,
Yeah.
these are things to consider.
Sometimes those quiet moments are end up being highlights for many
Mm.
days, weeks, months, years.
Yeah,
It's
absolutely.
Yeah, sometimes just when I used to go visit my friend in Kentucky, she's since moved, but one of my favorite moments with her, the first time I visited her in Kentucky, we did all this different sightseeing stuff and went on a
Yeah.
hike and did all this other thing, like went and got food and did all these things. My favorite moment of that trip was just sitting on her porch chatting.
Yeah,
And yeah, sometimes that's the best part.
sometimes that is the best part, just
Yeah,
sitting, being quiet. You can go
experiencing.
there are all sorts of things to experience, but sometimes it's good to have that
Hmm.
quiet. It is
Just be.
re-energizing to
Yeah.
be. It is.
I remember being
Um,
pretty little and my parents making me listen to a book on tape about how it's beneficial to be bored.
mhm.
When
Did you believe it?
it was a hard sell. I feel like maybe 5 years later, as a teen, I was like, I wish I could be bored right now. I want to be bored.
That's the thing, right? You as a child, "I'm bored. What do I do?"
Yeah.
And then, things in life start adding themselves. Suddenly you're doing music classes, you're
Mhm.
doing whatever, you know,
8 hours of
martial
homework
arts
at
or
night.
homework, or maybe you're in a school play or whatever,
Yeah.
you're volunteering somewhere, you're on a team that makes you play sports on the weekends. Oh my god.
Yeah.
You know, like, all of a sudden, all your hours are accounted for, and when do you have those moments? Yeah, and it starts younger and younger now.
Yep.
Yeah. Yeah. Gotta make
Yeah.
sure we got them. Ed was asking if the 7,000-foot altitude caused us any problems. I don't know. I mean, I did feel funky
Yeah.
for
But
a
we were also,
while, but
like, staying up late, we were on our feet all day.
and it was really dry too,
Yeah.
so yeah, there were all sorts of factors,
Probably
but
dehydrated a little bit.
dehydration. Yeah.
Yeah. So there was a lot going on, but I do think, I got winded easier when we were going upstairs and stuff like that.
Mm.
Um, Hot Rod, I did not get sick from the tap water. None of us got sick from the tap
No
water.
one got sick from the tap water, we were all fine.
Um, I guess there were some more far out areas in New Mexico. They were saying, like, if you're far away down a dirt road, you might not wanna drink the tap water, but otherwise, the big cities, they said were fine. Um, yeah, we did go to an oxygen bar. That was quite
We
the
did
experience.
that, that was funny. I
Yeah.
mean,
Oh,
I did not experience any benefit that I could perceive
yeah,
from the oxygen bar, but I also did not go into it with the most optimistic
right.
of expectations.
So I was
So, a
talking.
placebo, I mean, if there's an anti-placebo effect, that's probably what I had.
Right. Yeah, you're just willing it not to work. No, I was talking to
Yeah.
Brian about it. He said that, uh, they've talked at the hospital about how oxygen can help headaches.
It certainly can, and,
Yeah,
I didn't have a headache. Marshall, however,
yeah,
he was suffering, he was pre-migraine, and so he said it got rid of it, and he felt better.
yeah. Sounded like
Yeah.
there's some truth in
So
that.
so for him, it was beneficial. It was great, and maybe for you too, I don't know, but
Yeah, I mean, I didn't feel pre-migraine, but
right,
I was
partner.
feeling, like, the little tinge, and
Mhm.
sometimes, that can turn into a pre-migraine, that then if I don't take anything, it turns into a migraine, and yes, that does happen to me, even though there's lots of warning signs. For some reason, you convince yourself it'll be fine, and then you end up in a dark
Mhm.
room with a cold compress on your head, trying not to barf. But, yeah, I did have a little bit of a tinge, and I was thinking like, "Okay, next place we go get some food, I'll take some painkillers," and I kind of forgot about it after. So, yeah, I don't know.
That's good. I mean,
Yeah.
you could have just forgotten about it. Water
Mhm.
could have helped, sitting down could have
Sitting.
helped.
Yeah,
Just sitting and being
absolutely.
quiet in a nice cool place with some
Yeah.
cool water could have
Yeah.
helped. It could have also been the oxygen. But we do know that oxygen helps. Additional oxygen, if you have sleep apnea, it's great.
Yeah.
That, there are situations. Yeah, there are situations where it does help, but I think when you are a normal person, it's, like, so much related to health when you don't really have anything bothering you, what is it going to fix? What's it going to improve? What improvement are you going to notice? So
Mhm. Mhm. But what I do wonder also is they said prime. So you start to feel the effects. This is what they said. We don't know what's true about this, what scientifically is proven here, but they said you start to feel the effects around 15 minutes. You become quote unquote fully saturated, whatever that means, at about a half an hour. So we did 20 minutes. But what I started wondering about is what about those canisters where you just go, that's not 20 minutes.
no, it's not. I
So
think those canisters, breathing in and out of them. Or there are oxygen candles also that you can get where you break them and they produce oxygen, and those last maybe 8 minutes.
Huh.
So, they're limited. They're more
Yeah, but,
limited
like,
for
the little
sure.
cans with the
Mhm.
trigger, I thought you just kinda went and that was
Uh,
it?
no, I think they contain more than just one breath. It's compressed
But
air.
is that the usage? I didn't think you, like, sat there sucking on it. I thought that you
I
just,
don't
like,
think so.
took a
Yeah.
breath at a time, but,
Yeah.
um, but if that's the case, I'd feel like that's bunk. I don't know.
Yeah. What is that? Canister?
Yeah, boost
Canister for
up,
hiking. These canisters for hiking. Yes. Boost.
boost.
Oh, someone tested canned oxygen at 8,000 feet. Let's see. Does bottled oxygen help altitude sickness? A 15 or 20-minute dose of O2 can help alleviate mild symptoms of acute altitude sickness. So, potentially an oxygen bar would help if you are up, but one of those, so let's see. Let's see what this site tested it. How long do you get to just to huff the oxygen? Somebody grab their boost. Um, la la la. They got winded. Um, able to catch his breath because of the oxygen. Large size for long trips and a pocket size for short outings like jogs. What? Okay. The pocket version contains 2 liters of oxygen, which gives you up to 30 1-second inhalations.
Yeah, that's what I'm saying, that can't
Yeah.
possibly
Yeah. Maybe it can help with being winded, but the medium can holds 5 liters and over 100 1-second inhalations.
Yeah, so they're just going so
Yeah.
how can that possibly do anything?
I don't know. I don't know. I mean, it would add to your oxygen, your O2 saturation from that single breath, but it's not, I mean, it not significant. You'd have to take more breaths to really increase your oxygen saturation.
Yeah, that's just doesn't make
Mm.
sense.
Yeah, so Eric in Alaska, an oxygen bar on Denali would definitely be good business.
Huh.
Yeah. Flying out, yeah, so we were talking about it's 95 or 97% O2 or it's 100 O2% O2 in those cans. Air is normally, like you said, about 21%. And so we're not breathing 100% oxygen, which that would be bad for us generally. But in the situation of, in an oxygen bar where they put the tubes under your nose, not all the oxygen is going in. And so it is really just supplementing the oxygen. So the method of that supplementation may create a longer situation for actually leading to saturation. Maybe because of the mouthpiece that the boost uses for you to breathe out of, you get an actual 100% oxygen boost,
Hmm.
which you really don't wanna be breathing just 100% oxygen for significant periods of time, because that's not good for you.
Hmm. I mean, there's lots of anecdotal
Overall,
cases of
not so good.
people
Yeah.
saying the can does something, but
Mhm. Yeah, but maybe because of the way that it's inhaled because of the mouthpiece, it's
mhm,
like a more efficient delivery system.
maybe. Weird. I don't know.
Maybe.
Jury's still out for me.
Eric, the last oxygen bar you were in was a hospital. Yeah, no, don't go back. No
Yeah.
repeat visits.
Unless you need to, then go back.
Yeah, yeah, right, and if you have to, but try and avoid going back if you
Yeah,
can.
yeah.
Yeah.
Try to prevent it, but
Mhm. I'm back. Hmm. Yeah, it was a fun Santa Fe. That was a fun
Uh-huh.
experience. That
Mhm.
was that was that was great.
Yeah. It was very neat.
Yeah. I mean, honestly, the festival was cool, but Meow Wolf
Mhm.
blew my mind. Now I
Mhm.
need to go to Las Vegas and Denver,
Yeah.
Colorado, and I
Yep.
just need to follow Meow Wolf around wherever they build things.
Yeah. So, Vegas isn't open yet, I don't think.
Yeah, opening soon though.
Yeah. But Denver. For sure,
Denver's
Denver.
already open. Yeah, I was watching a little video of it. It should be fun. We'll find. And I honestly, if you are near someplace where you get an opportunity to do one of these experiences, you go to Santa Fe, like this was I've never I've been to Burning Man, people, and I've never experienced anything like this. It was amazing.
That's crazy.
Fantastic. 2020, Area 15. That's when the Las
Mm.
Vegas one is coming. Oh, I thought Denver was already open. Said it's coming in 2021. What am I missing here?
Oh, really? No.
One of them is already open, right?
Yeah, Kaleidoscape is supposed to be open.
Yeah. Yay. Good to
There's
be
a
seeing
Meow
some
Wolf
Las Vegas.
Seattle coming?
What?
Let me see. I'm just gonna go to Meow Wolf's website rather than read a bunch of bunk. Oh yeah, Denver says coming 2021. What the heck?
Mhm. Maybe they're not done with the whole thing yet.
I thought that was Kaleidoscape.
I thought it was too.
Like, why would they have merch in their store?
I don't know. Raising money to build it.
Hmm.
Hyping it. Hyping it a bit.
You can buy a lifetime pass.
I wonder if that's to all of them or just the Denver. I want one. Buy a lifetime pass. Want one.
They're so reasonably priced. I love it. The Denver one they're
Mhm.
saying is gonna be $25.
Yeah. I mean, it's priced to the area so that it's accessible to people. Like you can
Yeah.
more people can afford those prices. And if more people are coming, I mean, that's something about this group of artists. They're really great and they, they
Oh.
follow the idea of radical inclusivity for themselves. And I mean, they've gotten more businessy over the years for sure and had to focus on the business aspects, but they support artists and they want to be inclusive. And pricing of your tickets is part of that.
I figured it out.
What did you figure out?
Kaleidoscape is an open ride in Denver in Elitch Gardens, which is a theme and water park.
So they
That
just
is
need a ride at the park.
that is currently open. And they say Kaleidoscape is a condensed power shot taste of what is to come to Denver.
Oh,
Meow Wolf
cool.
is set to bring a new permanent exhibition to downtown Denver featuring incredible interactive art.
Cool. Okay.
Neat.
Nice.
I cannot wait to see
I
Kaleidoscape.
know. Love it. I wonder though, all the people going through and touching things and handling things, how often they have to fix stuff.
Yeah. I didn't really see anything that was broken.
No, I mean, by the end, they had some door issues when we were leaving.
Yeah.
Oh, lifetime pass. Access to all Meow Wolf locations for you and a guest forever.
Oh my god, how much is it?
It's $10,000.
Oh my God.
Really, what they're doing is they're trying to get investment
Yeah.
in their idea, and they're trying to get people to invest in what they're doing. Yeah. Unfortunately, I do not have $10,000 to do something like that. I wish I did. I think it's a wonderful. I love what they're doing. I really do.
Yeah,
I think they're doing good in the world with art. It's
they really
fantastic.
are.
Yeah.
I want to see Area 15. I'll
Vegas,
be
baby.
honest. I don't generally have a desire to go to Vegas.
Right. This would make me do it.
Yeah. If I find myself in Vegas, I will have something cool to do. That's great.
Oh, maybe I need to save my money to go to Vegas for their opening night party.
Yeah, for real.
That would be a
Or you
little
could just wait till the
investment.
following week and pay $35.
Yeah. Yeah. Just wait a little longer. It'll be great. But it's not a party with the Meow Wolf people,
Yeah, that's true.
which would be super fun. I want to go back. I'm going back to Santa Fe. Going back. Want to go
Yeah.
back.
I know. I have to bring Brian. He's going to love it.
Yeah. I hope that the Interplanetary Festival invites us back again next year.
Oh, yeah. It'll always be in Santa Fe, huh?
Uh-huh.
Yeah. That's great. Let's bank on that.
Yeah. Let's see if we can get them to bring us back again for more podcasting from Santa Fe. And then we can go to Meow Wolf again and we can expand the trip a little bit longer. I can go to Taos and see the rocks.
Isn't that where the Earth ships are too?
We can see the Earth ships.
Yeah.
Justin would be so excited about that. Yeah.
Yeah.
I'd have to expand it, make it a longer trip and do some real
Rent
and
a
do
van
some
too. Yeah.
yeah, get a van or yeah, something like that. And yeah, explore and do some videos or some
Yes.
yeah.
That would be amazing. I'm
I
super
like
down.
I like this plan for
2020.
for 2020. Yes, this is a good plan for
I
2020.
know.
I like
We
it.
should let SFI know.
I know.
Hey guys, we've already started talking
Hey,
about next year.
we
So
already made this plan.
I mean, I feel like our show was successful. I'll be interested to see when
I
they
think
send
so.
out the post-festival
The
surveys
night
and
singing
stuff,
saw
what
guy.
people say.
Yeah, I'd love
So,
to. Yeah, I'd love to know what people say if they saw it, if they liked it, what they thought. Yep.
mhm.
Yeah.
Yep.
Yeah, yeah, yeah. Newsletter.
Mhm.
I will open the chimp
Mhm.
now so I don't forget. I may have to tack it to
I'll open my text messages.
yeah.
It's annoying that it does that, but I understand why. It's because it has people's personal information in it.
Yeah. Yep, yep. Yeah. So
Okay.
you let me log in and then I'll have it for 2 weeks. But we can do some I'll try and do some writing tomorrow. If I can.
I could do
I
some
have
on Saturday. I'll set an alarm.
okay. Or the weekend.
Mhm.
Saturday, Saturday, look at all, it's Saturday. Mm, 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 mm. Okay, that'll be good. So let's try and get another, and I will figure out if I can get our guest next week to reschedule to another week. But we do have some guests that I'm lining up for July already, so we can advertise those.
Great. And I have to send you the
Mm.
stuff, the climate change sea slug paper I was telling you about.
Oh yeah, send me that.
Yeah, I'll do that tomorrow.
We'll do it. We'll do it.
You love Rochelle. She's very cool.
Cool.
Yeah.
I like that. Yes. Yes, please.
Mhm.
I think I met her briefly
Yes. You did.
Rochelle?
Yes.
Yeah.
Yes,
Yeah,
yes, yes, yes.
I had gone back and forth with her as part of the programming committee for the conference.
Mhm.
Let's see, what was my next question? Business. TWIS
Mhm.
business, because this is a business meeting in
Mhm.
which we talk about Meow Wolf and oxygen huffing.
Mhm. Mhm.
Calendars. Should
Mhm.
we set a date for at least starting calendar sale promotion?
Sure. So I think I will have the cover done. I think I can definitely set to have it done. I haven't painted anything yet, but I can jump into the painting. Um, I can probably have it done by the end of the month.
Oh, this month?
Yeah.
Okay.
Um, but yeah, I think maybe August we could start pre-orders. Is that too
Okay.
early?
No.
Okay.
No, I think if we were to do that starting like mid-August, I think that's fine. Yeah.
Great.
Yeah. I think people really start thinking about their calendars for the next year like in September-ish, but
Mhm.
yeah.
Yeah. Cool.
I think
Okay.
that's
Yeah,
good.
we can
Having
do that.
more time for pre-orders
Yeah.
is good.
Mhm.
Um
Yeah. And we'll know how many to order.
yeah, I will know how many to order ahead of time, maybe a
Yeah.
little bit better. Yeah. And okay, so that's calendar. We got uh I'll figure out the interview. We got newsletter. We got is there anything else?
No, just next week. Are you
Okay.
gonna try to find us another
Uh-huh.
person? Okay.
I'll try to find you another person
Okay.
if I can,
Okay. If not, we'll figure it out.
as you do.
As we do.
Yeah. It's so funny. I'm like, I know you both can interview people, but I want to be there.
Yeah, of course you do. Well, usually you have the book too, if it's about a book. So it's helpful to have you there. I don't have the source material.
I do all the thinking. I do all the thinking about it ahead of time. I'm like, I know what I want to ask this person.
Yeah.
Yeah.
Yeah, yeah.
Okie dokie. I think that's it for now then.
Great.
Yeah, it is bedtime identity 4. I didn't sleep well last night. I had wild dreams and then I kept getting woken up and then had
Oh no.
back to sleep and then wild dream and then wake up.
Yikes. What'd you eat?
Salad?
Oh, not a good explanation.
No, I don't know. We should get Diana Cowan back again. She's fun. Yeah, she'd be fun. To try and reach out and get some other people.
Mhm.
I still have to get back to Roger. We're doing co-host swaps
Oh
with
yeah.
Daily Tech News Show, and he sent me an email, and I need to get back to him about that. So we're gonna make that happen.
Yeah.
We will schedule it.
And I'm taping for that I don't remember what it's called. Oh no, I'm so bad. The Climate Talk podcast or something like that. Um
Oh,
so yeah, I think I emailed you about it a little bit ago, but it was like
mm-hmm.
months ago. It took a long time to schedule. But Noki suggested me, since I do this, to talk to them
Cool.
about the program. So I'm going to be talking about that and the zoo and this. It'll be fun.
It'll be
So
great.
once it's recorded and I have released information, all that kind of stuff, I can mention it on the show. But
Awesome, but you don't know when that's gonna happen yet.
no, I know nothing.
I don't know.
I just know when I'm calling him on the phone.
Awesome. Do it at
Yeah,
some point.
yeah, yeah, yeah. But I love doing other podcasts. It's fun.
It is fun. I think we should do more of that.
Yeah, I would love to.
Mhm.
Hear that, world? You
Yes.
want me to come on your podcast? I'll do it.
I'll do it. Blair will do it. It'll be fun.
Yeah.
Yes, we will.
Mhm.
Okie dokie. This was fun. It's always weird after a weekend show and then like, I gotta do another show.
Yeah, I
Okay.
know. It's very odd last night. Like, uh-oh, I have to look for stories again?
I know. I just did this. Oh my goodness. Back to it. Yes. It's a good thing I'm always reading about the science.
There we go.
Yeah.
Alrighty. Well, I had so much fun with you.
Yeah. Same here. It was
It
great.
was a great weekend.
Yeah. Great weekend capped off with another great TWIS episode. More fun hanging out.
Yeah.
Okay. I got to remember to keep an oxygen tank on my bedstand. Yes, Ed. I will do that. Yes, Eric, email me for an interview suggestion. Please do that. If you have suggestions for interviews, email me
Yeah.
because that
Mhm.
is more what I see and possibly remember.
Mhm. Mhm.
Things that go by in the chat, kind of, it's like,
Yep. It's like when a
ephemeral.
teenager comes up to me and says, next Tuesday, I have to leave at 2 because, and I'm like, send me an email.
I need to be in
I
my
don't
place where I can put it
know.
in the schedule and I can make it happen.
Yeah.
Yeah.
Any hoozle.
Say goodnight, Blair.
Good night, Blair. Say good night, Kiki.
Good night, Kiki. Good night, everyone.
Everybody.
Yeah, we will see you next week. And for those of you who like to catch me on the Twitch, I am going to change the time of my Twitch broadcast because of changes in time of things that are going on in my life. So I will update that on the website and tweet about it. I haven't put it in my calendar yet, but I'm thinking it'll be somewhere around 10 a.m. on Fridays. Might be the new time. We'll see. And it may work out great, but we will see. But that is what I'm going to try to do so I can do more Twitch broadcasts for you and not miss out on them for various reasons. All right, everyone. We will see you next week. We do hope, we do hope. And I need to remember which buttons I need to push. Have a wonderful science weekend, a wonderful science week. See you later. Bye.